So you have to know the physical properties of ionic compounds, and you have to find relationship between for that with the lattice structure. So number one, they have high melting boiling point. So this is the sodium chloride crystal in solid form. Then once you melt it at 808, it becomes molten, and the sodium and chloride ions are free to move about. So why it has high melting and boiling point is because the forces of attraction between the positive and negative ions are very strong. So a large amount of heat energy is needed to overcome these strong bonds during melting and or boiling. So if they ask you why sodium chloride has high melting boiling point, write something like this. If they ask for why magnesium chloride has a high melting boiling point, also write something like this, but your answer needs to change a little bit to answer the question. Okay. So then it does not conduct electricity in solid state. So the illustration is here. You have solid sodium chloride. Then you put it inside there. Then you put two carbon rods. This one is electrical conductor. So then after that you connect it, the light bulb doesn't light up. So then it tells you that NaCl in solid form does not conduct electricity. Then it conducts in aqueous and molten state. That means aqueous means dissolve in water. Molten means melt down liquid state. So when it's in liquid state, the ions are able to move around freely. Then that means right, they act as mobile charge carriers. So when they act as mobile charge carriers, you can have, you see this one, sodium chloride is in solution state. That means equal state. So then, similar to the one on top, but now this is in solution form, you will see that the light bulb lights up. When the light bulb lights up, tells you that it conducts electricity. So then the third trait is that they dissolve in water but not organic solvent. But not all ionic compounds dissolve. So this is the list, a list here where all which ionic substances will dissolve. Then they do not dissolve in organic solvent. Organic solvent means it's alcohol. So that is a checklist. You can just take down the checklist and check which substance is dissolvable and which is not. So we have come to the solid down here, solid sodium chloride again. So when it dissolves in water, you will see the water molecules. These are water molecules. So the water molecules can separate the positive and negative charges. So when they separate, when the sodium and chloride ions, right, they separate, then you will dissolve. You don't have to draw the drawing, but you need to know some form of explanation here. If you don't remember the explanation, you at least have to say that they dissolve in water but not organic solid. That line here, this is the super important thing. Then the fourth thing is, if you have ionic compounds, the dissolved substances, right, can be reobtained again using crystallization. I think this is chapter 1 or chapter 2 of this Sec 3 work. You know what's crystallization? Do you know what's crystallization? It's a separation technique process.
Crystallization can only be used for
Or use for what?
Salt.
So the next two uses are not very important right now, but then next year then it will be more important. So they are uses of some ionic compounds. Now down here, question. The diagram below shows the arrangement of positive and negative ions in ionic compound. Then they say name the term to describe this structure. Answer was
Crystal lattice structure.
Possible. Similar. Giant ionic lattice structure. Similar. Again, what is X?
Ionic Bonding.
Next one. Wow, this type of structure gives rise to the following physical property of ionic compounds. Explain clearly for each physical property listed below. So the first property listed is high melting and boiling point. So they want you to write the explanation. Write the explanation. So notice this. Explain. That means they expect some long answer with more detail. So do you want to type your answer out and then we check if this is the answer? Have very strong forces of friction. They need large amount of energy to break out of the attraction. Okay, so do you think it's answering the question?
Yeah.
They have who have very strong forces of attraction. So
the lattice structure.
There are very strong forces of attraction where between the positive and negative ions. So there are strong forces of attraction between the positive and negative ions. Then large amounts of energy is required to don't break out. We use overcome the the attraction. That one is overcome the forces of attraction, electrostatic forces of attraction. Like that. So you have to add a B here and there. So have strong forces of attraction. Where is the strong forces of attraction? It's actually strong electrostatic forces of attraction. So you want to tell them that the forces of attraction is between something and something. So it's the black one and the white one. Therefore, large amount of energy is required to overcome the forces of attraction. So it's a very good try down here. You're quite close. Okay, you want to add to your? You want to take down anything? Yeah, ready. Then we go on to the next one. I'll show you the answer. So electrostatic forces of attraction forces between positive and negative ions are very strong, so it requires large amount of energy to break them. So electrostatic forces of attraction forces between positive and negative ions are very strong, so it requires large amount of energy to put them. Something like that you can refer to. Next one. Okay. This one, they say, explain clearly why it conducts electricity only in molten or aqueous state, but not in solid state. Explain. So that means they expect something more in detail. Like how you did it for the earlier question.
In molten or aqueous state, the giant ionic lattice structure is broken down, causing the ions to be free to move about and conduct electricity.
That is when it conducts only in molten or aqueous state, but not in solid state. So you have to say why it doesn't conduct electricity in solid state.
Because the
Electrons? Did I hear electrons?
The ions are not mobile
in solid
state.
So they cannot conduct electricity. Yeah, very good. Close. In molten or aqueous state, the giant ionic lattice is broken down. As a result, the ions are free to move about to conduct electricity as they are held. Oh! Wait, I typed wrongly. They are not held strongly at fixed position. Next. State on another general physical property of ionic compound.
They are soluble in water but not in organic solvents.
Wonderful. Okay, now this one. Which one of the substances in the table has typical properties of ionic compound? A. Yeah. High melting boiling point and soluble. Which of the following properties best indicates that a substance is ionic compound?
It conducts electricity when molten.
Why cannot A? Why is the answer not A? Why not A?
Because crystallization is used for solids.
No. This one just means that you have a crystal at room temperature. That means you have like precious things like quartz and all that. They are all ionic compounds, and they are crystalline solids at room temperature. So is it possible that it is not a solid, that is not a crystalline solid at room temperature? Is it possible for ionic compounds to be not a crystalline solid at room temperature? This is what I ask. It can be in powder form, then it's not crystal. Then is it almost insoluble in water? Is it almost insoluble in water?
No.
It is soluble in water, not insoluble. Then it can be synthesized from its elements, means you can make them from its elements. So you can make, so if you want sodium chloride, then you can make it from sodium and chlorine. A. C is not very possible because the rest of the compounds you can, even if it's not ionic, they can be synthesized from their elements. So the closest answer is maybe just A and D, but I think D is a better